Today we are going to introduce the seamless visual sharing system with colorblind people. Color is a fundamental visual feature. However, there are people who cannot distinguish between certain colors. They are called colorblind people. Being colorblind is common. 4% of the world population are colorblind. One solution to help them is to recolor the image so that the colorblind could distinguish between the colors. Look at this example. The flower and leaves coloring is different in normal vision, but they are very similar in colorblind vision. We recolor the image so that the colorblind can distinguish between them. However, when switching back to normal vision, the color change cannot be accepted by normal people. So, can we find a visual sharing method such that colorblind can distinguish the colors while normal people would not notice the difference of the image? The low-cost 3D display nowadays helps to solve the problems. The 3D display provides two different views to the audiences. Usually, the difference is the object's positions in the image, which is also called disparity. That's why we see the 3D effect. In fact, besides disparity, our brains can tolerance for more differences in two views, such as brightness, color, and even contour differences. Note that the fusion of left and right views in our brain is different from linear blending on the screen. It tends to preserve high contrast content on either side. Thus, we have two different kinds of visual experiences. One is wearing glasses. We can have two images fused in our brains. Another is without glasses. The two images will linear blend on the screen and then perceived by us. By allocating these two visual experiences to colorblind and normal people separately, we are able to achieve visual sharing. The key idea is as followed. For colorblind people who will wear 3D glasses, we generate two different views in colors to increase color discrimination, such that they can distinguish the colors they cannot before. For normal people who will not wear 3D glasses, the two images will linear blend on the screen and it keeps the original colors. So, the problem becomes how to generate such image pairing. It is obvious that the more different the two images are, the more information they can preserve for colorblind. However, when the two images become too different from one another, viewing discomfort appears, which destroys the visual experience. Here we show an extreme case. If the two views are totally different from one another, they may cause serious visual discomfort such as flickering. So, to generate the image pairing, we need to maximize the color difference and keep them in the comfort tolerance range at the same time. Now to see some results. First, let's see an image used to test colorblind. The left is the input and the right is our results. Let's view them under colorblind vision. As you can see, colorblind could not tell how much the number is in the left side, but see 42 clearly in our results. Let's back to normal vision. If the two result images blend on the screen, we can see it is almost the same as the original image. Let's see another result. As you can see, the apples are difficult to distinguish originally, but it is easier to distinguish in our result. And the blended view for normal people is almost the same as the original. Now for a final result. It is difficult to distinguish the clothes of the football players in the original image, but it is easier in our results. And the normal view is almost the same as the original. Thank you for watching our video. You can contact us via the email or visit our website.